Hello and welcome to this video on Ethernet lag or link aggregation. So the idea of link aggregation is it allows you to take multiple interfaces, let's say like these two interfaces here, and bond them together into a logical interface. This works exactly the same way as Cisco's port channel. So the idea of doing this is you get many benefits of bundling interfaces together into logical interfaces. It means that you don't have interfaces that are sitting there not carrying any traffic, so you're not wasting the interfaces that you've got. And it adds redundancy as well, because at the moment, prior to this, all of our traffic was going from spine 1 to spine 2 via this interface right here. So if that interface went down, then we would start to lose potentially some traffic, even though we do have redundancy where the leaves are connected to spine 1, for argument's sake, or spine 2 directly. It's not really optimal, so we don't have redundancy in that regard, whereby if you have link aggregation, you can have one of these links physically go down and traffic can still flow over the other link. It also allows you to increase your bandwidth. On an XC interface, bandwidth is 10 gigs, and on a GE interface, bandwidth is 1 gig. However, if you bundle the interfaces together, then you can have a lot more throughput, so you can push more traffic down the interfaces than what you normally would. So for argument's sake, you can do in multiples, so you can have 2 interfaces, 4 interfaces, 8 interfaces, 16 interfaces that you can bundle into. I believe you can go all the way up to 64 in the end, which you can bundle together to increase your throughput and to increase your resiliency as well. Another benefit of having link aggregation is that you don't have spanning tree shutting one of the interfaces down, so you can have these two interfaces that are up in a logical interface, but because spanning tree will see this as being one interface, then it's not going to block one of them instead, unless of course these were all like aggregated devices, in which case that could cause a bit of an issue. Spanning tree will still have to do something with that. But aggregated interfaces also work on layer 3 as well, and you see this very commonly in the data center, especially when we move away from layer 2 and start getting into our IP underlay. You'll see that lag is used quite extensively for the purposes of redundancy and throughput. So it's relatively easy to set up. And what we need to do, we need to tell the chassis itself that it needs to enable aggregated devices and how many we want to actually select. Now, like with any logical interface, this will be called, say, AE. That's terrible. There you go. That will be called AE. And what can happen is that, let's say, for example, we only create one, so it would be AE0. You can subunit down. You can have AE0.1.2.74.392. You can subdivide these down like you can any other interface. And if we was to use a device count of 2, then we would have also AE1. If we use device count, say, of 10, would have all the way down to AE9, which is not too bad at all. So what we're going to do, we're going to jump onto the command line of spine 1, and we're going to set a interface up. Now, another thing to bear in mind with these interfaces is that they don't have to be continuous. So our bottom interface is XE0/0/0, and our top interface is XE0/0/4. That's not a problem at all. So they don't have to go in order. So you don't have to do XE00 and then 01. You can do them in any order you like. And if you're using a switch that has multiple line cards or multiple routing engines in there, then you can split that across multiple routing engines as well. So let's jump onto spine 1 and have a quick look. So the first thing we need to do is enable the aggregated Ethernet itself. So let's do set chassis, aggregated Ethernet, or aggregated devices rather, and then we tell it what devices we want. So do a question mark, we see that it's Ethernet. And now we do our device count, and this is how many aggregated interfaces we want this device to make for us. So I'm going to just choose 2, and let's commit that. So the first one's going to be interface AE0 and the second one's going to be interface AE1. So what you do is with the aggregated Ethernet or the AE interfaces, you set them up exactly the same as any other interface. So let's set up our AE0. So set interface AE0, unit 0, family, Ethernet switching, interface mode trunk, and then we will put VLAN members, and let's put our 100 and 200 in there. Okay, that's it. So that's the aggregated Ethernet interface done. Now we need to bind a physical interface into the aggregated interface. So let's have a look and see what we actually have on our interfaces. Run show interface terse. Okay, so XE004. Now let's do show interface. Do we have any config on XE004? Yes, we do. So let's delete that. So delete interface XE0/0/4. All right, so that interface is now removed from the configuration. Obviously, it doesn't have any bearing on what's physically installed on the devices. So now let's do set interface XE0/0/4. And then we're going to do gigabit options. So if you scroll down here, you see you've got your giga ether options. Now in some older devices, this would just be down as ether options. So let's do giga options. And now what we need to do, if you do a question mark here, you'll see that we have the 802.3AD. That's the standard, or the IEEE standard for Ethernet lag. So we're going to do 802.3AD, and then do another question mark. It's going to ask us the bundle, which aggregated Ethernet that we're going to actually join. Now you see you have options for LACP. You don't need to use this for a basic aggregated Ethernet. So let's do AE0, and let's do a show pipe compare. So when we commit this, what's happening is that we're adding interface XE004, we're giving it the giga ether options, and we're attributing it to the IEEE standard of 802.3AD, and we're binding it to the logical interface of AE0. And then if we look further down here to the actual interface AE0, we set this up as a standard trunk port. So let's do a commit check. Okay, and let's see what happens here. It's not enabled for Ethernet switching configuration checkout. Okay, let's fix that. Okay, let's do a commit check now. So what I've done, I removed the XE004, which was set for RSTP, for spanning tree, which is what was stopping the configuration from going through. Let's do a commit check again. Fantastic, let's commit that. So the proof is in the pudding. Let's have a quick look now and see whether or not the interface is up. So let's do a run show interface AE0. Sweet. Okay, so as we can see, the interface on the link itself is actually up, and it's got a 10 gig link. That's absolutely fine. Okay, so what we can do, if we do a detail, so show interface AE0 detail, what happens is further down you can see which actual interfaces are part of the actual bundle. See, it says here that the member links is 1, so we have 1 member in the link, and it's showing us what physical interface is part of the actual link. In this case, it's XE004. So what I'm going to do, I'm also going to add this into rapid spanning tree. So set protocols RST interface AE0, and we'll commit that. And what we're going to do now is we're going to unbind what's currently on GE or XE000 and add that into the actual lag itself. So let's have a look and go delete interface XE0/0/0. Sweet. And then do delete protocols rapid spanning tree interface XE0/0/0. Okay, and what we're going to do, we're now going to bind interface XE000 into aggregated Ethernet 0. So set interface XE0/0/0 giga ether options 802.1 AD or 3 AD rather, and it's part of bundle AE0. Sweet. Let's do a commit check. Let's see if this goes through. Okay, looks like we need to remove it from RSTP first before it will allow that to go through. Okay, not a problem. Let's just delete that line and let's commit. Okay, so that's now been deleted from the RSTP protocol. So let's now add that interface in to the aggregated Ethernet with the set command, and let's commit that. See, when you're using the Juniper operating system, it goes down line by line. So we were trying to add the actual XE00 interface into the rapids, into the aggregated bundle, but as far as RSTP was concerned, it was still part of RSTP, so we needed to remove it from RSTP first, and then we could delete the interface and then add it into the Giga Ethernet options. Okay, so sweet. Let's have a little look and see what we can find with this. So let's do a run show interface AE0. Okay, so the physical link is up. That's great. Have we included it in RSTP? So show protocols RSTP. Yes, we have, so that's fine. So let's have a look at the detail on this now and see what we can find. So at the bottom now we can see that we have our aggregated member links is 2. And we can see that we have XE000 and 004 that are now part of the bundle, which is exactly what we want. If you notice, however, the speed of interface AE0 is now gone from 10 gig to 20 gigs. That's fantabulous. Let's have a look and see if spanning tree is still working as expected. Show spanning tree bridge. Okay, so RSTP looks to still be up and running. Let's do a run show spanning tree interface. Let me make this a little bit bigger. And as we can see, AE0 is part of the spanning tree interfaces, but you can see here that the port cost now has changed from 2000 down to 1000, because on a 10 gig interface the port cost is 2000, but we've doubled the speed, so we've halved the actual port cost as well. And we can confirm this by having a look on spine 2. So let's jump over to spine 2 and let's do a run show spanning tree bridge. And as we can see, that cost to get to the root is 1000 and the root port is on interface AE0. So there you go, we've successfully set up Ethernet lag on between spine 1 and spine 2. We've given it redundancy, so if one of the links goes down, this, so if XE000 or 004 goes down, then either one of those, then we still have redundancy because we have 2 links bundled in this. We've doubled our throughput, and we're no longer wasting a interface that could be better used for transiting traffic. So fantastic. There you go. We can also have a quick look to ensure that we still have reachability. So let's have a look. This is from the last video. Let's see if we can ping server 5 from leaf 1, server 1 on leaf 1 to server 5 on leaf 3. See if that goes through. There we go. Absolutely fine and dandy. Let's try to server 3. That's brilliant. Let's jump on to server 2 and let's do a ping 10.10.200.4. There we go. Absolutely great. And server 6. So brilliant. So there we go. Our spanning tree is working exactly as expected. We have full reachability on the compute layer between all the servers, and our two spines are connected via Ethernet lag. I hope you've enjoyed this video, and I look forward to seeing you in the next one.